Hello, my name is Connell Fullenkamp. I teach economics at Duke University. What I'm going to talk about right now is time value of money. Time value of money is a basic financial tool that we use to value things like financial instruments, projects, and even entire companies. Basically, there are two things that we need to talk about. We need to talk about compounding, which is how we take a financial instrument that earns interest and becomes more valuable in the future, and the interest earns interest on that. And we need to do discounting, which is to take a future string of cash flows and find out what their value is as of today. In order to do this, I'm going to start by introducing two tools that are very, very important in time value of money problems. The first of these is the timeline. Let me draw a timeline for you and talk about what it does. A timeline is simply, as its name suggests, just a line that you draw and you mark off with different time periods. You can put them above or below, but I like to keep them below because it makes me think of that we're doing stuff on the real number line. And all I do is I mark off the time periods on the bottom, starting with period 0, which of course is the present. And anytime we find the present value, we're finding the value as of time 0, which is now. And then we have our periods into the future. Notice I'm not really associating a time period with this. We can talk about that momentarily, about the different types of periods that you'll use. But the main purpose of doing using the timeline is then to associate the cash flows that come at each time. So you might have a cash flow that comes at, say, period 0, and also I'll call that CF sub 0. Here's a cash flow at CF sub 1. Here's another cash flow at CF sub 2, etc., and so on. It seems like a very simple and almost useless tool at this point, but I assure you that when things get really complicated, the only way to think about what you're doing and the only way to keep the problem straight is to use the timeline. And it will always save you and always guide you the right way to do the time value of money problems that we're going to be talking about. So I encourage you very, very strongly to use the timeline, even in the simple cases until you get used to it. But I know that from my own experience in teaching time value of money that when students run into a problem with evaluation, it's because they're not using the timeline. So there's the first tool, and we'll keep using this throughout our discussion of time value of money. The second tool is the interest rate conversion formula. It's important to talk about interest rates before we talk about compounding and discounting, because interest rates we think are very simple things, but they are actually a whole lot more complicated because they're quoted in 3 different ways. Let me show you. The first way that interest rates are quoted is in a periodic rate. A periodic rate, as its name suggests, is an interest rate per a period of time. Say it could be a monthly rate, or it could be a yearly rate, or it could be a semi-annual rate, which is a 6-month rate. So a periodic rate is an interest rate per period of time. Let's contrast that with something we could call a stated annual rate. I also like to call the stated annual rate the annual rate compounded m times per year. It turns out that most often when we quote interest rates, we quote them on an annual basis. But there's one other piece of information that's very important, and that is how many times are we compounding that interest rate? For example, if you have a credit card, your credit card interest rate might be quoted as an 18% annual rate, but it is compounded every month. That is to say, they reset the amount of interest and principal that you owe every month, and they do the compounding on a monthly basis. That leads to the question of, if you put a balance on your credit card on January 1, say $1,000, how much are you actually going to owe at the end of the year if interest is accruing from January 1, the day that you make the charge, all the way to the end of the year? Let me introduce one more concept before we try to contemplate what is going on there, and that will put all these 3 concepts together. The third concept in interest rates is the effective annual rate. An effective annual rate really asks the question, what would you owe if your interest rate was quoted as an annual rate compounded 1 time per year? So in other words, what it does is it takes a stated annual rate or even a periodic rate and converts it to a simple interest rate. What would you owe at an annual rate compounded 1 time per year? What I'm going to be doing is trying to relate the effective annual rate, the stated annual rate, and the periodic rate to each other, and I'm going to use a formula to do that. In doing that, what I'm going to be denoting by R is the stated annual rate. R is going to be compounded m times per year. I'll put a circle around that and draw a line here. The periodic rate, on the other hand, can be found by taking R and dividing it by m. So if you have a stated annual rate that is, say, 18% on your credit card, compounded 12 times per year or monthly, then the periodic rate, or the rate per month that you're going to be paying, is basically 18% divided by 12, which was 1.5%. The effective annual rate, I'm going to use another notation for, which is R sub EAR, the effective annual rate. What I'm going to be doing in a second is putting down an equation that helps us see the linkages between all three different interest rates, and that'll be something that we'll need to keep in mind as we do these time value of money questions. So let's do an example that tries to illustrate this connection between the effective annual rate, the stated annual rate, and the periodic rate. Again, think about your credit card. If you have an 18% stated annual rate, compounded monthly, say you put $1,000 balance on the credit card as of January 1, and your credit card company charges interest from the day that you make the charge. That's a little bit different from the real world, but this will help illustrate the point that I'm trying to make. If we look at the board, what I've done is just calculated then our $1,000 balance times the monthly periodic rate, which is going to be, again, 18% divided by 12, which is 0.015 or 1.5%, so that at the end of 1 month you owe $15 in interest. Say you, instead of paying off that balance at the end of January, you let it accumulate in with the credit card company, so that at the end of January you owe $1,015, and at the end of February then you're going to owe not $1,030, but 1,000 times 1.015 squared, and then at the end of March to the 3rd, April to the 4th, and so on. So that by December 31st, if you charge $1,000 on January 1 and just let it sit and don't pay off the account, what happens is that every month the credit card company compounds the interest rate at that periodic rate of 1.5%, so that by the end of the year you owe 1,000 times 1.015, here's the principal and here's the interest payments, compounded 12 times for a grand total of $1,195.62. That actually would be your effective annual interest. And so we can take this example and look at the formula that relates these things. And all I've really done is written down a formula that describes what I've just put out in this example and in words. It turns out that 1 plus R, the effective annual rate, is equal to 1 plus R over M, where R is the stated annual rate, compounded m times per year, raised to the m. Using our example, we can calculate the effective annual rate using our credit card stated annual interest rate of 18% divided by 12, because it's compounded 12 times per year or monthly, raised to the 12, is going to give us 1.1956 for an effective annual rate of 19.56%. So in that way, we see the relationship between these three different ways of stating interest rates. It's going to be important to keep in mind because in certain circumstances you'll want to know what the effective annual rate is, because you might want to compare the interest rates offered on different types of investments on an annual basis. The way to do that is to compare the effective annual rates. Oftentimes in time value of money problems, what we really want to know is the periodic rate. So if you think about what rate we're going to be using to discount, it's going to be a periodic rate. On the other hand, if you use a financial calculator, often the financial calculators will adjust to a periodic rate for you, and you'll actually input a stated annual rate. And I'll be sure and point that out when we do some time value of money problems.